Oh, good afternoon, everyone. Glad you can spend some time with us. Welcome to the Cybersecurity Collaborative virtual briefing today on CISO developed DevOps supply chain best practices. I'm Tom Skura, the moderator. And before I join my host, I'd like to say welcome once again to members, friends, and guests. We're all here today, and in part because of familiar events with SolarWinds and the Log4j hack, recognizing that vulnerabilities and hacks are now getting into software code and affecting the integrity of the supply chain. For that reason, Rockwell Automation and other members of the Cybersecurity Collaborative organized a task force specifically to identify what organizations developing software or porting software or consuming it can do to ensure that the code they receive and the code they send out is the code, in fact, that's theirs, has been checked and is secure. What we've come up with is 5 impactful practices that the collaborative members put together. This is for members of the collaborative. It's available right now in the member portal. But for those who are not members, again, guests and friends, this will be available to you. We'll show you a link, an email link where you can request it. We'd like you all to have it, and we all hope it will be very useful to you. 5 impactful practices sounds very general, but there's a lot behind each of the practices. And as we know, the challenge is not developing the practices, it's implementing them. As we know, strategy execution is much harder than strategy implementation. But in this document, if you really follow those 5 practices and work on them, you are going to greatly strengthen your development area. So I'd also like to mention too that in the document we do reference a number of vendor tools. The collaborative is organized independent of vendor influence. We don't have any relationships with them. However, we do discuss vendor tools because you absolutely do need them to run a security program. And there are a lot of valuable tools that can help you in managing the integrity of the supply chain with regard to software. So we do have a list of tools on the back of the document, and in this presentation you will mention some. They are not endorsements, they are what some members have used. And one of the advantages of joining the collaborative is that we do discuss them and members understand the pluses and minuses of really using these tools in their security programs. So we don't shy away from them, but we aren't advocating for any tools. So with all that, I'd like to introduce Andrew, who's the Senior Vice President of 2U, a great member of the collaborative. Andre, I'll give you a chance to talk about your background and also tell us a little bit about 2U as well.
Thanks, Tom. I've been in the industry for quite some time. I'm not going to date myself, but since the mid-90s. So I've seen some interesting progressions of technologies, especially on the software engineering side. I split my career between software engineering and cybersecurity, or information security as it used to be known. And so a lot of years of dealing with problems really went into some of the recommendations that you'll see in this document. I'm currently in charge of all of cybersecurity for 2U. We're an educational technology company. And so we deal with a substantial amount of student data, instructor content, have many large university partnerships. And so it's an interesting ecosystem in terms of all of the elements that we have to come up with a really good customer-facing solution.
Excellent. Thank you very much. Well, we're delighted to have you here to share your experiences at the collaborative and also your extensive background going back to a time when security was well contained and more about mainframes, and it's evolved since, quite as you know. So thank you again for being here. Housekeeping members, housekeeping items for those attending today. If you have some questions, there's a Q&A box there for which you can enter your questions. We will address them most likely at the end of the session in the last 10 minutes. If we get to them sooner, we'll certainly address them as well. So that gives you a chance to ask questions. Again, I remind you, this is for your time. If you have a certification, as Andre, I do, and many of you have, this is worth 1 CPE of your time. And I will encourage you for non-members to send in an email and request a copy of our 5 impactful practices document. You'll also get a copy of this presentation, if that helps you as well, to present some concepts to your own management and staff. So what I'd like to do before we get into the subject at hand is just kind of refresh everyone's memory and about what we do, what the Cyber Collaborative is in terms of creating value for cybersecurity leaders. We are a collaboration forum. We value member sharing through various vehicles, both peer-to-peer direct messaging, task forces, and virtual briefings, et cetera. We're all under an NDA. We're vendor independent, and we're all here to try to help each other because we believe that we can get better value out of our programs through direct collaboration and experience. So what is it specifically we offer? We have a library of CISOs developed tools and resources. We are vastly expanding the content, and the CISOs and members of the collaborative are sharing tools that they use that are valuable to them. One of the most recent ones was a ransomware preparedness assessment, which gives you a heat map of where you are along key ransomware controls and helps you develop a plan for improving your ransomware preparedness. That's the latest addition to the tool. We have the boardrooms, and I mentioned task force working groups that focus on different privacy and security topics. One of the things that all members value is receiving a daily morning report that comes in at 6:30 EST. So you're never blindsided about major news. Certainly, there's a lot of news about Log4j and other potential hacks, ransomware hacks, and vulnerabilities that come in that report. There's the 12-week cybersecurity leadership program that we offer for improving leadership skills, incident management skills as well. And then we have the CISO Ask the Expert Rapid Response. If you have a question, you can address it to your peers, and your peers will help answer that question. To that end, when there are major events like Log4j or the Russian-Ukrainian situation where there are concerns of cyber attacks, we will initiate member sessions, and we'll run them for several weeks to decide how to understand what the situations are and how to collaborate them. And for Log4j, we produced an advisory on member recommendations of what sources to look at and what to do. And for Russia and Ukraine, we've done that similarly. And if there were any events or attacks, we would assemble the organization to work on collaborating to see how we can address those issues. So there's a lot of value coming out of collaboration as well as content. So the topics we want to cover today will give you background on the task force that was put together. Talk about a couple of key threats to the software supply chain that I mentioned them. They were the impetus for this task force. And then we're going to delve into the 5 impactful practices for ensuring DevSecOps code integrity. There's a lot behind each of the practices. Again, you'll have the document in this presentation because there's plenty to absorb, but you can have it for you after the session. We'll talk a little bit about member-cited tools and resources, summarize our findings, talk about new task force initiatives, and then we'll have a Q&A at the end. So I'd like to kind of talk about the DevSecOps Supply Chain Integrity Task Force. There were organizations representing different industries and government agencies on this. We believe that a cross-industry view is the best way to come up with best practices. Members openly share their successes, false starts, challenges in these sessions. They meet once a week, probably over a course of 8 to 12 weeks. We have a structured agenda, so it isn't rehashing the same items. We come out with deliverables at the end of these sessions for the members. And one of the key values of being in these sessions is just being able to ask a question to another member about a product they're using, about a problem they're having, and even collaborating outside of the team meetings. So as we say, there's value from collaboration as much as deliverables. Andre, I don't know if you want to add anything else from your perspective about having been a member of the task force or being a member of the collaborative in terms of what you find valuable.
I would. Thanks, Tom. One of the beauties of the data that you're about to see is that it's all based on real world experience. There's nothing theoretical, there's nothing academic. Every member of this task force, which I was privileged to be part of, it lives this stuff on a daily basis. And that's important because you're not getting fed a document that'll lead you on a path, at the end where you'll turn around and go, okay, what now? This is real world stuff. I will say that in the past, these type of documents, especially the quality of what you're about to see, this would take an entire think tank of people that were put together from either academia or they worked together in that think tank and got paid to come up with this stuff. This was a labor of love for every one of us that was part of this task force, and I'm really happy with the end result. And so, Tom, over to you. I'm really excited to see this.
And thank you again for your leadership and input, which made all the difference on this. Okay. So let's talk about threats to the software supply chain. They've always been there, but we'll just remind ourselves of why we're here and why we need to follow these 5 practices. The SolarWinds attack, as we know, was attributed to a Russian group, Cozy Bear, APT 29. It compromised updates SolarWinds Orion software, which was a network and apps monitoring platform that we all used. The way to look at this on the right side is that there are 300,000 SolarWinds customers. A little over a third of them used Orion, which was the software that was compromised. A little over half of that were actually compromised. They downloaded the compromised version. Hard to estimate costs, but a BitSite analysis indicated that it was $90 million in insured losses to deal with incident response requirements and forensic services to figure out how this was impacting organizations and at what level and how to clean it up, which was a significant amount of money. It was through a modified plugin. This is how this can happen. The tragedy about this is how it could have occurred. As people used to say, right before you wrap up the candy, it put something bad in it. It was described in an analogy. I'm not sure I like that analogy, but it's a good one in the sense that sort of right at the end, something happened where you introduced this Trojanized component that was digitally signed. It was a backdoor communicating to third-party servers controlled by the hacker. They might not control their own servers, but other servers that were vulnerable and susceptible to attack. It was dormant for several weeks, and it executes, well, any kind of command you want to execute once it's file transfers, executing files, rebooting machines, destroying information, etc. Powerful in that it was a very pervasive attack because so many people use SolarWinds, and it was planned by that group to do that. It was discovered by FireEye, and it signals future attacks on widely distributed software systems, and it raises continued concerns with trusted components. So the problem is trust. Here, we all trusted this, and yet that trust was breached, certainly not intentionally, but it happened. And what we want to do is talk about how to prevent that from happening. The other that's more prevalent and more current is a log4j vulnerability. It allows remote hackers to gain control over vulnerable targets. To perform remote code execution, attacker only needs to send a simple malicious request, contains a formatted string, and then is picked up by the log4j library. This one too was prevalent in so many different software repositories, libraries, embedded code, cloud apps, and Salesforce, SuccessFactors, which many of us use, with software providers. Again, it's a vulnerability in software, highly prevalent, a large footprint. It was of such concern, as I mentioned before, that at the Cybersecurity Collaborative, we formed a working group so that members could collaborate on how to address the vulnerability. And we put together an advisory on remediation guidelines. What are the most reliable sources for patching and so forth? And there were some sources that were reliable and others that weren't. People would patch and have to redo things. Well, that's some of the stuff that we discussed and members were able to avoid because they had information from other members based on their experiences. So here we have Apache. We have the log4 vulnerability with Apache. We have SolarWinds. And that's why we got together. Actually, we were together before log4j, but anticipating it. So our team came up with 5 impactful practices saying, and there's a lot to do because if you're a developer, you're under pressure to produce. And at the same time, we want you to produce securely. And I've seen that dynamic go on organizations for years. Nevertheless, the threats are now in our DevOps area. So what's the first practice? Okay, everyone will say, well, all right, tell me something new. Maintain a comprehensive and effective cybersecurity program. First of all, what does that really mean? Most of us now, if we're handling our customer confidential information, could be personal information, proprietary information, we are now being asked to have an audited program like ISO 27000 or a SOC 2 Type 2 report. So this is not new, but the pressure's on to make sure we do that. At this point, if you're developing software commercially, you really should have a comprehensive set of security controls modeled on an industry standard. And there are multiple ones. PCI could be used as one, some do. Adequately funded. So yes, you have to have the funding for it. You can't be talking about it. Well-defined roles and responsibilities. Here's an example of, and that includes with your cloud providers, who's doing what. But if you're in an incident response situation and you don't have the authority to shut down a network segment without going through a whole bunch of approval channels or communicating to your user base without going through a massive review by your internal PR department, you can't act quickly. Your roles are not well defined. Your responsibilities are not granted to you that you need. So that's a struggle for all of us in this profession, but it's important. Continually tested and improved. Yes, penetration tests, vulnerability scans constantly. You have to use the technical testing. And it really does need to be independently audited. No one likes audits. Preparing for ISO 27001 audits certainly are not fun, but if you have a good auditor and you've got a good system, it actually becomes something valuable to you. So why do we need this? We're in the applications development group. You think of security as defense in depth. What we're doing in development is we want to reduce all avenues for hacks to hackers to attack the applications and data, not just the cold vulnerabilities. So in other words, cut down the avenues of attack. And there are means of coming in through ransomware. I mean, there are a whole host of means, as we all know about, that aren't just relating to the integrity of the code. So we have to give our developers a safe background to work in. And remember too, that applications and data are where hackers seek to cause disruptions in operations or for financial gain. So it's a very basic thing, but we need to maintain it. I just want to say there are two things that the team came up with that I say are very important regarding DevOps integrity. One is maintenance of an identity and access management program. Having an inventory of software components, hardware components, configurations, addressing vulnerabilities through this program, and then continuously monitoring the health of that is pros. And what we want to do is actually, it's ITAM, pardon me. So we have an ITAM implementation guide that we put together. And within that, understanding what all the components are extremely important. The second thing is the systems development lifecycle. Security requirements defined for each development phase. Threat modeling, security design reviews, code reviews, peer reviews, tests, and formal sign-offs. Audit trails of activities are extremely important as well. And developers trained in SDLC security practices. Many companies aren't doing that. Sometimes we've seen companies say we have very senior developers and we don't need to train them. So maybe I'll turn it over to you, Andre, from your perspective. Having an ITAM program, obviously identity access management is part of that, and having an appropriate systems development lifecycle with security embedded in them. In your experience, how important is that, and what are some of the challenges to doing all these things?
So it's of paramount importance, simply because if you take a look at most of the security issues that we've had in the past, let's say decade, an overwhelming majority are basically due to horribly written code. Let's face it, and I've been in this industry for some time as an actual software engineer. Most software engineers, and there are exceptions, but not many, don't care about security. They don't, because it slows them down. It adds work to their day-to-day functions, and they're on these tight deadlines. They have to deliver. And all of a sudden now your unit testing, for instance, for edge cases becomes a burden. And it becomes a burden that will possibly be a hindrance in terms of you hitting a deadline. And so it's just something that never gets done. And we end up with these situations. I mean, look, just recently, a Linux kernel bug was found that's been around for almost a decade. So somebody made that code mistake a decade ago and nobody's found it. And so, that's just the reality of the software engineering industry. And, on the flip side, most security practitioners couldn't write 3 lines of code if their career depended on it. And so we have this dilemma of, meet in the middle. And in that middle space is where the real magic can happen in terms of secure software development. But it takes a lot of discipline and a lot of buy-in from the business to add the time necessary into a cycle such that code can get written in a more secure fashion. But until that happens, we're going to remain in this type of state.
I think that you hit on the crux of it. I've seen organizations, they battle security because they were on such a digital implementation track. They had some major business objectives that the first thing is security gets in the way of it. So let's push it aside. But then, then we introduce problems in our code. But I've seen some organizations overcome that by bringing a trained security professional into the process and then using a tool like Jira or something to discipline the SDLC so that the sign-offs and stuff were not so burdensome, and then they can move on. I mean, using some tools. I don't think it's ever solved the problem, but I think it's helped the problem in my experience. Yeah. The second, okay, now that we've talked about a comprehensive and effective cyber security program, the second thing is reduce the attack surface. So we have the outer rim, which is the program. The inner rim is actually find some ways to reduce the attack surface for the software development folks. And we have three methods for doing that were recommended by the team. One was segmentation, which is we're very familiar with that. There's use of firewalls, ACLs, different types of devices to physically and logically separate the development environment. I would say before, everyone was concerned about the development environment and like R&D bringing in malware into the entire organization. Now it's the entire organization being an avenue into the software development side and introducing problems. So it's a little bit of a 180 on it. I mean, it goes both ways, obviously. Software-defined networking in the cloud environment is another way to do that. Make sure your configurations are proper. And reduces the exposure to threats and vulnerabilities is what you want to do with the segmentation process. Then there's another one called time boxing. This is an interesting concept. Limit the runtime of development assets. Reduce the availability of development environment to attackers as unpatched software rises over time. I think you just mentioned something, Andre, about something that was, well, we didn't know what it was. Maybe it wasn't unpatched. Ideally limit the duration of development workflows. Some mentioned 30 days, but afterwards, either you patch it or tear it down. So you build an environment and you tear it down. And I'll come back to you, Andre, if you have any thoughts on this. And then containerized builds, again, there's special builds, but they limit the attack surface. You can leverage automation to build on demand and tear down at the end of the build, if you're using that technology. And you can enforce code integrity controls like code signing, verification, storing images in authorized code repositories. So I don't know, Andre, if anything, I mean, segmentation's been around, not always implemented. Containerized builds, fairly recent, but, and then this concept of time boxing. Have you, I don't know what your experience in the effectiveness of these things, are they difficult to do or change the mindset of the organization toward these things?
So it's a mixed bag in terms of difficulty. I will tell you, segmentation in modern day cloud environments is a lot easier than what it used to be when you had to go deal with a network administrator, right? There's a level of agility that exists now that just, in the past was not there. And so I think there's a lot of promise there. I will go back to my discipline statement because I think that's key. All of these mechanisms are effective so long as someone has the discipline to implement them. And I'm going to give you a real example real quick. Take offshoring, for instance. An organization, let's say, will hire QA engineers offshore, right? They want to save money, and that makes total sense from business. And so you have these remote disparate teams that are running QA on some work that's being done here in the States. And, it's not uncommon for our software engineers or any software engineer to work till 4 a.m. till they're exhausted. And they've exposed their work to the internet so that these individuals can test the work. There's no VPN going into a software engineer's home. People are working from home. And all of a sudden, 4 a.m, you're exhausted, you fall asleep, your server's still out there, world facing, internet facing. Guess what? Anybody can get to it, right? And if you think that the nefarious entities aren't scanning the entire internet constantly, you're delusional at this point because it happens all the time. And so all of a sudden, take that same software engineer's development workstation at home, and he took a database dump or she took a database dump from work, didn't sanitize the data because why would they? And that all of a sudden now you have a real database on that user's machine. They fall asleep, it's exposed to the internet. By morning time, the data's leaked. These are real scenarios. And so if that developer didn't have the discipline to take that entity offline, none of these mechanisms are helpful. And so that's why I'll always go back to that discipline, because the human factor is really the weakest link in the chain here. And so, yes, these are great mechanisms so long as you train your teams to have the discipline to use them.
I think you hit the nail on the head. Discipline is it, but again, along with discipline is this pressure to release on a certain date, right? And taking, scrubbing a file, it's extra time now for me to do that. I'm not arguing that they should take it home unscrubbed for the very reasons that you said, but the pressures in the extra time to do that while they're trying to fix code and add different functionality is always on the developers. And, there has to, you're right, there has to be the discipline and the respect for the discipline and allowing the discipline to govern, when things need to be done, or if things aren't going to be done properly for the very reasons that you've mentioned. And that's hard. I think it has to, management has to kind of, while they're advocating for getting these things done, have to advocate for the discipline. Like, you have to do it within this way. And if you can't, then raise it up to me. I think you're absolutely spot on there. So we talked about the effective cybersecurity program, bring the attack surface down so it's less available to the hackers. But the things that we also need to do is harden development processes and the technologies that support them. So we talk about continuous integration, continuous deployment of an agile concepts that many organizations are now deploying. When we say harden that project, make sure we're doing static code analysis, scanning for keys, secrets that are in applications. And again, these are some tools that members are using, Trufflehog and the GitHub Advanced Security, to identify these things that shouldn't be there, that expose weaknesses to the software. Software compositional analysis as well, and open source vulnerability management. And they, again, it was a reference to Black Duck to discover and manage open source risks. So tools are very, very important to bring in here. I know there's an expense associated with them, but we're not writing perfect code, and there are vulnerabilities, and there are open source vulnerabilities. Here are two that tools that members have cited. Automated testing functions. We know about DASD, interactive application security testing, and automated scanning with review of results. These things must occur. Again, if there's a problem or security vulnerability, it needs to be addressed. We talk about quality and doing things right the first time, so you don't have to go back and redo it. That was the big quality mantra. Well, we have that challenge here as well. I mean, if all of a sudden you've developed something that's insecure and you found about it at the end of the process, you got to go back and redo it before releasing. Leverage compliance checks. There's PCI DSS, CIS benchmark scans are good. My experience, you really have to look at the results on that and have someone interpret what to do. You can't necessarily always consider all vulnerabilities addressable from those things. And developer control security configurations like HTTP headers. So that's the first part of it. The second part is managing our keys. And this is important. The keys are the keys to the kingdom, basically, is we have to protect. Keys and secrets are in many places during development and runtime. I think that's, we can get sloppy on the management of that. What we're saying is key applications include code signing keys, SSH, PGP, API tokens, AWS, and authentication credentials. Manage and store keys securely. Don't store them in a code repository or a file system. So you should centrally manage them using a hardware security module or a secure key vault like Microsoft Azure Key Vault or HashiCorp Vault. We really have to look at the way we're using keys and how they're stored and managed, and not having them embedded in our development code repositories. And that's a different discipline and a different set of technologies. Assure there are no secrets in your code by enforcing the systems development lifecycle. processes and code scanning, and again, looking for those secrets, and to keep the secrets out of the build environment variables and employee direct access from secure storage. So again, I'll go back with your experience, Andre, in terms of hardening the environment, in terms of the CI/CD process and key management. That sounds like a huge challenge, but it sounds like it's something that can be done that might really improve things if we're disciplined to do it. What's your take on that?
Architecture matters. And I bring architecture up because if a solution isn't properly architected right off the bat, we end up with these situations. And take crypto keys, for instance. It has been and still is to some extent a common practice to just embed a key in your code. And so, for instance, let's say your code is going to run on a mobile device. And let's say you're doing MTLS, mutual TLS, right? So you're going to have a private and a public key on the client side of the machine. How do you protect that? So unless the phones have, software-based HSMs, or unless you're, at some extreme level, you have a hardware-based module for a phone, that's an HSM, that becomes extremely challenging. And so there's no clean solution to this. It really comes down to methodically designing the solution that you're trying to implement and really taking every measure you can to not put those keys where they can be exposed. Now, if your solution is more on the server end of the equation, you do have, especially with most modern day cloud providers, you do have some good options in terms of protecting those resources at that level. Really shame on you if you've designed a solution that will expose crypto keys of any sort and you're cloud-based. That's just really sloppy work at this point.
Right. Is there a lot of training that needs to go into that with developers in key management, would you say?
I think so, because most developers don't really understand cryptography. They don't need to. They just make API calls to do encryption and decryption. And so long as they pass the key in, or the bytes for the key, stuff works, right? So who looks under the hood at that point? To your point earlier, if I'm working on a tight deadline and I need to implement crypto, hey, here's an API, I make sure the key is valid, good to go. I'll just embed the key in my code and we're solid, right?
Right.
And that's where the problem starts.
Yeah, good point. Very good. All right, so let's move on to the next area. And let's see. So hardening the environment, another key part of this is to employ strong identity and non-repudiation methods. In other words, you want to make sure if I'm writing the code for Andre's organization that I'm authorized to do that if it's from me or the area that I'm working in. And there are three pieces to this. One is developer identity. How many environments have we seen sort of shared identities in developer environments? There should be unique, verifiable identity, no shared identities. Is sometimes people want to do it, they're in a hurry and they want to, but there should be a verifiable identity to know who's doing what. We also found implementing Git commit signature feature was something that was very valuable for team members, because PGP key is used to sign commits, and only signed commits are accepted in the code base. So again, there's some level of authorization in terms of what's being put in there. And then SSH was preferred over HTTPS as a transport and authentication method for Git. Then there's machine identity. And looks we're kind of getting into zero trust here. Critical to maintaining DevSecOps infrastructure, especially for cloud deployed software, typically managed through SSLs, TLS certs. Members for managing machine identity do talk about the value of using a machine identity platform so that they're away from the search and the timeframes and things being out of date, et cetera. An identity platform like Venafi to avoid maintaining the search. They found tools like that to be very, very useful. Then the third part of employee strong identity and non-repudiation is code signing. Typically only employed with discrete applications as hosted applications published directly from a repository. But the thing is, only the software publisher has access to the key required to sign the released code. Modification of the code post-release removes the signature, which guarantees the software authenticity and non-repudiation to the consumer. So it's signed and guaranteed. To protect the security of the private key, again, we mentioned using an HSM and grant conditional access based on approval and context in a time-based amount of time. So it's not forever, it's approved using an HSM. Implement 101, 1/1 approval where managers sign off to ensure no individual has access to the release keys and can, alone, and maintain separate keys for development and release. So again, this whole business of using keys and managing becomes all the more important for maintaining the integrity of the software you're developing. Again, it's a challenge, and there are tools you can use, and you have to train the developers on it. But if you don't do that, then you risk the integrity of the code. What you also need to do is maintain audit trails, very important. And you can do this once you digitally sign stuff. Logs who signed what and from what machine, maintain a hash to the signed binary, periodic audits, paying attention to release keys, particularly to make sure if they're no longer valid, that they can't be used. And this, again, we were mentioning a code signing platform like Venafi. A code sign protect is something that was very useful. So obviously, strong identity, code signing, keys to do that are very, very important. They sound cumbersome, if you're trying to get code out the door. On the other hand, if we're trying to prevent a piece of software being put in by someone or a process that was unauthorized, this seems to be a valid technique that should be considered. What are your thoughts on that, Andre?
This is super essential. And it's probably one of the more overlooked areas in terms of a software development ecosystem. Everybody's after agility, right? If you look at the agile methodologies that have come out, it's all about getting stuff out the door faster. And faster does not equate to more secure. As a matter of fact, it equates to less secure in a lot of cases. And so, again, having the discipline to implement some of these mechanisms and use them on every commit, it becomes essential. I will say, I talk to a lot of people who look for ways to implement advanced technologies like machine learning. This is a classic area where machine learning can actually add real benefit. No hype talk, none of that. If you think about the audit trail logs that you just mentioned, Tom, that'll generate a substantial amount of data, right? Mm-hmm. And if we can ensure that, for instance, every commit is a signed commit, key-based signed commit, you can have an algorithm that'll tell you what the outliers are in case somebody tries to make a commit that is not properly signed, right? That's a real effective, a real world use case of using a technology like ML for real security benefit. So I do think this is probably one of the more important areas of this entire conversation. And it's one of the pain points that, if you try to implement this into an existing software development practice and they don't have these disciplined practices, it's going to be a sore area in the beginning. I can tell you that from firsthand experience.
Again, it comes back to employing these techniques, having appropriate technologies like ML or code signing protect systems, and 3, the training of on the developers to know how to use and employ these techniques in the development processes. It all takes time. It takes time to get to that point to be able to do it, against shoving code out the door. That's what we're always up against. But again, might this have been, I don't know what happened in the SolarWinds specifically, that maybe this could have been employed to help it. I'm not sure. On the other hand, it does help protect. If you know who your developers are, what machines are being used, and who's signing what, it greatly reduces the risk that someone's going to interject code you don't want. So let me, I know we're a quarter of, let me get through the last parts and then we'll open it up to poll and questions. The last thing is to manage the integrity of code in the supply chain. So you've got all these things in place, but again, you're getting code between deliverables, you're getting open source code, you're getting third parties code. So, and there's been some questions on that. Definitely track deliverables between teams. Code released by one team equals a code consumed by the other. For open source code, this is a challenge and it's come up in questions. What the team is suggesting is have us in a development organization, have a small team curate open source dependencies in an internal repository where they can be evaluated and not everyone's pulling in open source stuff, and force all other teams to consume that. Now, again, a little more resource to do that and a little more differentiation in your software development team to be able to do that. On the other hand, open source is significantly a risk factor. Support crowd-funded open source code audits. You know, the more we can do of that and then have those consumed in those small teams. And use distributed ledger technology to track ongoing change history of open source projects. So the other thing is third parties. Here is the rub. The dependency risk is huge. I'm getting software from suppliers, third parties. No firm has sufficient resources to adequately review all third-party code. That's for sure. So there's a little bit of implicit trust that's required, and so only consume well-maintained projects, and then support artifact repositories and software build-in materials to maintain a chain of custody throughout the SDLC process. We've heard about software builds and materials quite a bit, Andre. In your view, should we be doing more of that, or what's your thought?
Definitely more. I mean, this log for, I say log4x because it's log4j, log4shell. Right? So the log4x situation showed how in complicated ecosystems, which, you know, J2EE type ecosystems are fairly complex, some of these libraries get pulled in indirectly. So the developers didn't even mean to implement those libraries. They came in as part of a framework or part of a dependency that was downstream to the actual work the developer was doing. And so unless you have a clear asset inventory, in this case, you know, a BOM type inventory, unless you have that inventory really laid out for you, you're kind of operating blind within some subset of your project, right? You just have to take it on faith that those libraries are going to be there and that they're going to do the right thing. And I think in the log4x case, we saw where that goes bad, right?
Right, exactly. That's a very good point. And again, SolarWinds and Log4j are the ones that bring all this to the fore. By the way, Connor has put a poll question up. I encourage you all to address this, and we'll continue on while people are taking the poll questions, and get your questions in about 5 minutes. Okay. So talking about member-cited tools and resources, in the appendix of the document that we want you all to have, we have member-cited tools that they use, some information about those tools, and a link to find out more information about those tools. And the members have talked about code signing solutions that they use, container management, insider threat code review, key vaults, ledger-based dependency validation tools, machine identity management tools, repository managers, scanning tools that they found useful, and then supply chain integrity guidance and frameworks from NIST and other sources. So again, using the best practices, all of these types of tools fit in with those things. If you're looking to improve certain areas, here's some member-cited tools that you might find useful. And I say it over and over again, we're not sanctioning that from the collaborative, but I want to stress that when you join, this is your opportunity to see how members are using these tools and how effective they are and challenges they've had with implementation. Because these are things that we talk about all the time in task forces. So to summarize the 5 impactful practices, and I won't get into all detail, start by making sure that you have a comprehensive and effective cybersecurity program. Reduce the attack surface into your development area. Harden development processes and the technologies that support them. CI/CD and key management we mentioned. Employ strong identity and non-repudiation methods. And then given the supply chain, open source and third parties, make sure you have some control over the selection and use of third-party and open source software in your environments. Let me just, before we get into the questions, just want to go over the new task force initiatives that we're getting involved in here, and then we'll turn it over. We have a couple of questions in the Q&A. One thing we've done is we've concluded the 3rd and 4th party incident response task force. We've delivered a guidance document, a best practices a checklist, and supplier scorecard. We're putting that together. There'll be a virtual briefing on March 15th at 2 o'clock. We hope you all will join us then as well. We're starting a new task force on security awareness training, methods for greater engagement and effectiveness. We find that members want to go share their challenges and also tools and techniques that they're using for increasing and improving awareness, not just in phishing exercises, but in communicating policies and being able to get their end users to identify vulnerabilities and incidents. So we'll be starting a team. We encourage existing members and new members to join. And then we're putting together an aggressive agenda for task forces that we're going to initiate this year and produce quite a bit of content out of them. There'll be a boardroom security communications task force to produce templates used at the board, incident management task force to produce playbooks and also tabletop exercises. Security metrics will be a focus of this team in terms of interactive metrics that members can use and benchmarks. Monitoring SOC SIEM will be one. For CISOs, one of the big discussion at the executive committee is how do I mentor my staff to eventually become CISOs in this role? As we know, staff is moving up. We have a shortage of staff, so staff development and acquisition is a big area that we'll be addressing this year in the collaborative. Identity and access management will be a specific topic that we'll focus on. Application security, talking about SDLC and some other things that we've mentioned here. And then we'll have a couple briefings on quantum computing and its impact on encryption and data regionalization relative to privacy regulations and concerns. So with that, I want to just remind everyone to certainly put down 1 CPE credit for today's time. Contact us for a copy of this document and we'll send the presentation as well. Thank you for addressing the poll questions. And let's go to some of the questions we have in the chat box right now. So in the Q&A area. Okay, so this is one tool to enforce and maintain. We got this. I'm maybe missing that. I don't know if you can. Okay, I don't know what the if whoever, I think it was Dennis. If you could, this is one tool to enforce and maintain discipline. Maybe it's a comment on this, I hope, or if there was something else. But thank you very much. We had a question: is the membership free? This is a paid membership, but I'm not at liberty to say what that is. Do me a favor. We have the services typing in the answer to this. Please contact us. He'll provide an answer to do that. So great. Thank you, Dennis, for getting back to this. Are there any other questions? We got about 5 more minutes. I didn't know if anyone else had anything else. My only other question, I would say, and to Andres, is one that we raised before a little bit in how do we get all these disciplines into the development organization? Now, that's a tough, loaded question, you know, because we're talking about developers now having new tools, new responsibilities. There's more money being invested in this, perhaps having a group to look at open source. I mean, the threats and vulnerabilities are right at the doorstep here. So how do you avoid it? But I don't know I'm not sure of the answer to bring that up to management. I mean, obviously CISOs seeing this and being aware of some of these vulnerabilities would have some ammunition. But any thoughts, Andre? Don't me to throw you this one. This is a tough question.
Well, I was just thinking, if I get the answer right, I'm going to go play the lottery.
Yeah, you can play the lottery. I'm just telling you how grateful. Let me just say this now: how grateful I am, and all the people who attended here, to have your expertise on this call. You know, not only in developing this document, but really sharing some insights. But I just wanted to make sure that you got those accolades, because I know we're all grateful, and it shows. That you have a lot of knowledge in this area and expertise. But that being said, I'm not trying to set you up for how to do this. And
No.
so you have some good answers from the audience too, came up.
So I will say this, and by the way, thank you for that, Tom. I will say this: it's a company culture issue, right? The support for these type of initiatives have to come from the top. And if they don't, they'll never be implemented. For example, one gentleman, I answered one question there, who was talking about his experience in terms of going through mandatory training, coming onto a new job, and that there were repercussions for violation of their policies and stuff like that. That's awesome, right? I can't tell you that's the norm from what I've encountered out there. And I've worked all over the world. Literally, I have 8 stamp passports right here. So when it's not part of the company culture, you have a serious challenge on your hands, because people are going to cut corners all the time. They're just going to want to get stuff out to market. And so unless the business really supports the fact that secure delivery is the objective, not just delivery, until that cultural change happens, we're going to remain in the same current challenge that we have today.
Do you think CISOs should just have a lot on their plates, have more discussions with their management about code that's being consumed and developed, particularly in an organization that is developing a lot of software and using it, you know, at least impact discussions like, you know, look at what happened, Log4j, et cetera. If this impacted us, here's what could happen, and to our reputation. You know, more that, you know, not trying to scare anyone, but there are, we can't solve 100%, but we got to get from the 85 to 98%, something like that.
Yeah, I think the FUD, fear, uncertainty, doubt model, I don't think that's ever worked, right? You can get short-term results out of that, but it's not really an effective model. Right. I think factually addressing, for example, what you just said, look, there's negative brand impact if we get hit in, you know, way X or way Y. That's real. You just keep it at a business level. I mean, look, business people understand dollars and cents, right? And so you have to show them where it's going to hurt, and then they're going to listen to you, right? They're not going to listen if you just come and say, hey, we have to do this for the sake of security. I've learned that the hard way in my career. You know, you can tell I've come up to the tech ranks. I've lived this stuff. I had to come to terms with the fact that executives just don't look at the world the same way we do, right? But you just learn how to talk to them at that level, and I think you can get those type of changes implemented in an organization.
I think that's good advice. Last thing, I'd like to call something from Alex Ruse. Supply chain of developers, early intervention in training developers in secure coding and concepts, even beginning secure coding as early as university studies, et cetera. Companies need to do more in this space. Invest in your developers. And I like that. Thank you, Alex, for sharing that with the audience here today. And with that, we're right at the top of the hour. I'd like to again thank everyone for spending your time with us, and thank Andres again for his expertise and putting all of this material together and in enhancing what we presented with real world experience. Please send us a note if you're interested in learning more about the collaborative, and please send us a note so we can send you this document and the presentation, and reach out to us if there's anything that we can do to help you with this tough endeavor. Thanks, everyone. Have a great rest of the day, great weekend. And while we're only on Wednesday, got a few more days of work. Take care.
Thanks, Tom. Bye.
Bye.